Good morning, everybody. Welcome to our webinar on the core insulated foundation system. We'll just give a minute or two for everybody to join, and then we'll kick off. All right, we'll just give another 30 seconds or so, and we'll get started. So today I'm joined by my colleagues, specification manager Chris McComb, and our site support specialist, Pork Booth. Pork is very experienced with the core insulated foundation system. He provides on-site support for our customers. So we've got a very good webinar lined up today with lots to go through. So we'll get started now. I think we've got a good amount that have joined. So we'll just start off with a bit of an introduction and just some housekeeping. So today's webinar is hosted on Teams, as you know. We are recording this as well, so if you have to leave at any point, we will make the recording available to anybody that has registered and joined today. We do have everybody muted for the presentation. However, you're free to use the Q&A feature at the top of Teams. You'll see it at the very top of the program. If you have any questions throughout the presentation, feel free to drop a question in the Q&A, and we will address it at the very end of the session today. Likewise, if you need a CPD cert for your continuing professional development, we are happy to provide a CPD cert for yourself at the end of the presentations today. If you can email us marketing@coresystem.com with the name of yourself and the company. If there is one, we will organize to send a certificate back to your email address. And just to go through a bit of the agenda today, so we'll jump straight into about the core group, a little bit about the benefits of EPS and core's products. I'll then introduce Chris, our specification manager, who will talk about the basics of the core insulated foundation system and why you should use it. And then we'll hand it over to Pork Booth, who will talk about the practical application of the foundation system on site and some of the misconceptions around that. And then we'll finish off the presentations today with a question and answer session. So who we are the core group. The core group is comprised of two companies, Core Insulation, a manufacturer of expanded polystyrene, and Core Retrofit, who's a one-stop shop for the SCAI One-Stop Shop grant scheme, among many others. So again, we're comprised of Core Insulation and Core Retrofit. We've been in business for nearly 3 decades, and we employ more than 130 staff across both organizations. We're an award-winning manufacturer of EPS insulation for a wide range of applications, and we'll get into that a little bit later. And then on the Core Retrofit side, again, it's a SCI registered one-stop shop offering full grant administration, quality and project management across a number of grant schemes. We specialize in hard-to-treat properties and low-energy retrofits such as EnerFit and Passive House. Our products are NSAI and BBA certified, including core fill bonded bead and the foundation system. We're on a pathway to sustainability. We are ISO 50001 certified. We've gone on an exceed journey at the factory here. Our products are EPD verified. We've completed a certified net zero pathway, which included our 1, 2, and 3 scope emissions. And we're the first Irish company to achieve an accredited greenhouse gas verification. And here on the screen, you can see all of our memberships and associations. So MMC Ireland, Hardware Association, Passive House Association, IGBC. And just some of the benefits of EPS. So it's a high performance material made from 98% air. It doesn't compose, it'll last the lifetime of the build. It's water and moisture resistant, lightweight and practical. It offers a good price for performance ratio. It's compatible with many applications. It's eco-friendly. We have a low carbon alternative as well. and it's non-toxic and certified. And these are just some of the applications that we offer for EPS: floor insulation, the foundation system, cavity wall insulation, external wall insulation, roof applications, including core lock, core loft, and flat roof. And Chris will go into a bit of detail on the foundation system itself. So Chris, I will hand the presentation over to you, and I'll join back at the end when we do the Q&A.
Good morning, everyone. Thanks, Brian. So I'll just run through just briefly the what the insulated foundation system is. So it's a fully engineered system. The system achieves a U value as low as 0.10 by default, and when you're looking at floor targets and underfloor heating targets of 0.15 and 1.8, it is an exceptionally beneficial system to use when you're looking to achieve a low U value. Meets pretty much any ground condition, with the ideal sweet spot for the system being 100 kPa ground bearing capacity. It was the first NSAI certified system in Ireland, and now we're also delighted to say, as of the end of 2024, we are now BBA certified as well, with a couple of large projects ongoing in England as well. So that's a great for ourselves. So with the system, you're virtually eliminating any thermal bridging by wrapping the entire foundation in a continuous layer of EPS. The system combines two of our EPS. So EPS 300, which is our structural compressive strength EPS, and then our EPS 100, then with concrete and steel reinforcements that form the foundation and ground floor slab. As I said earlier on, it is a fully engineered system. None of this system is off the shelf, so it is designed and engineered per each house type. The system then also uses a reinforced concrete slab with thickenings to carry the structure above. One of the big benefits of the system you'll see when Porrick goes into the install process of the system is that the speed that the system can be installed in. So one of the big benefits is that it reduces costs. You're taking 40% of your concrete out of the build, so you've no need for block layers on site. And then also another big benefit to think about with the system is that when the install happens, the installers that are approved and we would suggest, they would be installing your system in sort of 4 to 5 days. So the speed on site is really quick, cutting your program on site from anywhere from 20 to 30%. System pretty much is suitable for all construction types. Our two most popular would be ICF and timber frame. They would be the two most popular, but we also do a bit of steel frame and traditional block also. Porrick will go into this in his presentation also, and show you around underfloor heating. But underfloor heating fully works with EPS as well. I say Porrick will go into that in more detail of how it works. There's two ways to do it. In the concrete slab or above, we would suggest in the concrete slab, and as I say, Porrick will go into more detail in his presentation of around how that works.
That's perfect. Thanks for that, Chris. I'm going to hand it over to Porrick now. Again, Porrick is our site support specialist, extremely knowledgeable with the foundation system. So over to you, Porrick.
Thanks very much, Brian and Chris. Morning all, it's Porrick proves my name. Over 12 years in construction. Been using the core foundation system for almost 5 years now. I've installed well over 100 or so foundations using the system for the different types that different variety that can go in for ICF, timber frame, etc., as Chris covered. So what we're going to discuss today is we're going to go through some practical application of the foundation on site, plus 7 minutes to just typically misconceptions about the installing of the system. So I wanted to just go through them with typical kind of questions that we have on site. So typically there's a lot of questions we ask regarding the T3 blinding, how to get it level and what's required for it. Is it structural? We'll go through installing the profiles, how they go together, how to keep it in place. That's the misconception can be that it's insulation won't stay in place. But again, we'll clarify all of that. Using the M combs or the fixings used to put the profiles and everything together keeps everything very tight. Removing the temporary shutter formwork from the F profile. So simply for a timber frame or a profile, it's for a twin leaf wall. So we'll go through that side. Is the radon needed? So you wrap it back up to the deep, exactly as a DPM. Why do you have to do it? Again, like Chris mentioned, installing the underfloor heating. Is it compatible within the foundation system? We'll go to that side. And then just again regarding bracing profiles, do you need to brace them or why do you need to brace them? So the first misconception, as I mentioned there, was you can't get T3 compacted and level to install a foundation on it. Some concerns are it's sand. How do you get it so level to be within tolerance? But the T3 can be easily compacted and installed to a certain level. So you install the first 30 mil, compact that. You get it all firm and to the required level. And then once you compacted that laser, you'd get your laser level, you'd set tubes into the T3, set them at the top, middle, and end of the tubes, that their level, and then you can use a screed rail to screed off the top of them tubes, while that's screeding it and compacting it in at the same time, and it all keeps it within tolerance. So again, here it's just typical pictures from the various different sites that we've used. The T3 in, you can see laser levels in place, the pipework is already in, T3 has been leveled. So to work your way through it, it's easy to do it. You can do it for step foundations, foundation beside each other, you put a break into it. So like I mentioned, you set your tubes, use your laser level, set your tubes and take it. Getting the T3 right will make the process so much smoother for the install. It is dictating your level, it's blinding there. And it is dictating the level for the rest of your foundation, and it just makes everything go so much smoother. So this is an example of just the tubes that are used, the tubes and screed rail. So again, the tubes are set laser levels, you use top, middle, and end, that's leveled in, and use the screed rail to work off of that then, and that also provides a compact final layer when it's installed. The next misconception is often asked, it's insulation. This is strong enough to take the concrete and stay in place. The way the system is designed, it's to make the profiles easy to keep straight. You have M cones, new pins, hold everything to hold the foundation system in place. By doing that, you also control the alignment during the installation while the concrete is poured. You properly use these components and carefully place the steel. The system maintains a true stable profile, so getting it straight isn't difficult. So it's a typical thing of when you're installing
Here we have
the
an S profile.
Sorry, we have a video play that'll go through some of the details for us.
Here we have an S profile foundation being installed. Again, timber frame unit beyond the inside, allows for external masonry on the outside, external outer leaf masonry blockwork. The lads here have started at the corners, worked their way around, worked from corner to corner, install the pieces as per their number sequence, as per the drawings. The string line then is used to ensure everything is kept straight, and you control the lining of it. As they went then, they've cut out their drainage, external drainage, within the profiles to ensure everything is installed at this point. And now you can see inside the foundation then, they're now installing the perimeter insulation. They've installed the perimeter EPS 300 insulation and now doing the load-bearing wall insulation.
So that was just a rough video to go through the install process taken on site. So in the pictures we have here, you can see string lines are already set up, ready to go. Your radon has been in place and getting ready to set up the profile. So again, ideal having cross member cross-member profiles with string lines up so that you can build, you have your fixed lines and you can build and install the core foundation system to the string lines. You're also ensuring with the string line you can check if there has been any creeper movement within place. So again, you typically start at your corners, work across the drawings that are specifically done for each individual foundation. We'll have measurements on them so you can check your angles, and make sure everything is 90 degrees and square within place. You work your way across, you'll see that typically every profile will have a specific number due to the installation or to a reference to the installation drawings. Each foundation gets its own, has a specific installation drawn to it, which makes it very easy to follow and to install the system. It's done step by step to help you install the whole foundation system. Here then, from within these pictures, you can see profiles have been installed and some of the perimeter EPS 300 was laid in. But again, you can see the string lines are used to control alignment. Once everything is in place, you can install your M combs, which again braces out, it pulls up the profiles together, keeps the profiles in place. There's extra strong grip from them, which you'll see later on. That again just controls everything. But by having your string lines and cross members up, you can see that the whole thing is in line. It's flushed together, and so you work from your corners, you check your 90 degrees, and you know you're fully happy with the position of the foundation. Here again, it's just an example of different corners and stuff with the profiles. You can see the M combs in place, typically three per profile. They're a very strong system. It keeps everything in place, so you can again control the alignment of it. So it leads on to our next misconception of you don't really need any M combs or pins. That should all just go together. That would be incorrect, or missing M combs can cause gaps, misalignment, and potential core bridges. They're also what keeps profiles tight and aligned, providing stability while the concrete is poured.
So when they've installed the profiles and have lined it through, you then use the M comb fixing, which is going to hold each profile together. There's the very strong strength in these that it pulls everything in very tightly. So there'll be three per joint, one installed in the outer ring beam like so to be hammered in, the one in the high part of the upstand, and one on the inside of the foundation then. And that'll hold all the profiles together, and it helps to keep the line all the way around.
So the next misconception which can just arise typically with an F profile, that by doing an F profile, it has an outer ring beam, but also provided with the insulation, so there's no core bridging from the external leaf to inner leaf. It's a system used where you have a twin leaf system, simply a timber frame or steel frame, or again masonry, and it'll have an external block work on the outside. So the outer ring beam takes the external masonry. So by doing this, the core foundation system is able to do this, but the whole profile is made and installed, so you don't have to come back and use a shutter. You don't need to use a shutter when pouring the outer ring beam. It's very bespoke system for this system. But by doing that, the external ring beam, the external insulation, which is temporary formwork, needs to be removed. So if you leave the EPS too long, it can make the removal harder and damage the profile edges. Should be done the day after the pour. Removing it on time also makes sure the footpads and drainage can be installed properly. So again, to remove the F profile, the external shutter, we'll see there's a cut line provided where the arrow is there. There's a notch mark provided on the insulation, on the profiles, to give you an area of this is where you're supposed to provide a cut. Once the concrete has been poured and set, you cut along this line, ensuring that there's no undermining of the foundation system. And also by doing that, once you install that cut, it loosens it away from the concrete. So once you have the cut line done, remove the M combs that had in place holding each profile together. Hit the top of the profile with a hammer, something like that, just to loosen away from the concrete. And once you've seen that kind of come away from the concrete, You'll be able to just hit it away and the whole thing will come off in one piece. As you can see in the picture, there's profiles came off. It's all in one piece. If that is left for too long, it will fuse and bond to the concrete, which is going to make it a lot more difficult to remove. It come off in pieces, and it gives a lot more chance that you could actually damage the system itself. Then here's more pictures to show that the temporary shutter has been removed. You can also see at the top of the slab that just recess has been left in the slab for access way for doorways. But with the profile, I say it's been removed, and you've applied the cut along that cut line to ensure that there's no undermining of the foundation system. That everything's sitting there and it's all ready to go ahead of wrapping up the radon and installing the blockwork. So another common question is radon barriers. You don't need radon barriers. In particular, everywhere you will be installing a radon barrier. So it is important to install a radon barrier that suits the site conditions alongside the foundation system. So again, depending on the radon levels or what's required, with their different variety of radon barriers. Want to extend it outside the perimeter to ensure that it is out far enough, and we can wrap back up. The membrane acts as DPM then once it's outside the footprint of the building, and it keeps EPS dry and protected and from any solvent contaminants getting at it over time. Wrapping it is fully essential, not just a nice extra.
But so here we have an F-profile foundation. This foundation benefits a timber frame house with external blockwork masonry on the outside. You'll see that the temporary shutter has been removed. The outer ring beam concrete has been poured. The radon has been wrapped up the external ring beam, back up the upstand, and left to sit inside. The timber frame will come then with its DPC below its sole plate, which overlap that, and the EPS has been protected from any contaminants or solvents coming through it, but also there's a DPM there to prevent any moisture coming inside.
So typically it was just the F profile one. So again, with an L profile, if you're using it for ICF for different structures, that would be the very same process. That's wrapped back up, and a cement board would be applied or installed to allow that it finishes, but also then protecting the system as well. But you need to ensure that there is the radon comes up and there'll be a DPC from the inner leaf construction process. So here are just examples of radon been installed, fully wrapped back up. So again, it follows the outer ring beam across for the threshold, back up the upstand and within the slab. Again, for these examples, it's perfect to show that everything is fully protected and nothing, no solvent or anything can get at the system. Again, it is a crucial part of the NSCI agreement that we have. It is a design process that has to be followed. And here we are. Here are examples of the L profile. Then you can see it wrapped back up. It's wrapped back up. All penetrations have been sealed, and there's a cement board then put across at the desired level to ensure that that is also protected. But then that gives you a surface then that you'll be able to finish with, if it's your render or acrylic or whatever external finish is being installed. So again, a very common misconception that is raised with the foundation system is underfloor heating. There are concerns regarding that there's too much concrete on it, it's insulation, or maybe it's not designed. Well, it's not true. Underfloor heating system works perfectly with the foundation system. Extensive computer modelling, independently verified, confirms performance compatibility between the underfloor heating and the insulated foundation system. But the concrete slab may take slightly longer to reach a stable temperature. The analysis shows that heating and cooling cycles are reduced, which actually improves the system's efficiency.
Right, so here we have an L profile foundation. This is again a semi-detached unit being used for ICF that's used on this, and start bars coming about. But it can also be used for timber frame with external insulation, external cladding. What you can see here there is the underfloor heating pipes are installed on top of the final layer of the EPS 100. So that's 150 mil below the concrete. There's different methods to install the underfloor heating. This is one of the recommended ways to do it. I said there's thermal models have been developed using this system to show that it has the same output and maximize the thermal mass of the area. So it's installed on top of the final layer of insulation, clipped down, and it's ran through the walls and then turned up for its manifold. And this allows for the whole area the underfloor heating in an area to spread, and the insulation holds them within place. Its generation to generate the power at the very start, the heat at the very start, would take an hour to 2 hours max more, but after that there'll be very little thermal loss from it.
As mentioned there, that there's been transit thermal models have been done on this, so it can show that the system is fully compatible and it works, and the process of it. So if there's details required for underfloor heating or questions regarding it, which we have to contact ourselves, and we'll be able to go through the system to show that the model is there, that it can be used. There is different processes of installing it, so it depends on it all depends on the person, but we would recommend of doing it within the foundation system, and say with the insulation, everything everywhere heats, but all the models and the figures can be provided to ensure that it is a fully adequate design for yourselves. So next misconception we often have is bracing profiles. Is bracing required? And keeping it true that it's insulation, it's going to move. So will I have to shorten the whole thing after installing the insulation and the profiles? You don't require it. That the system is held together using supplied end combs and U-pins to keep everything stable. Some people like to add extra bracing, such as blocks or scaffold planks. This system usually needed as long as care is taken when installing steel and placing the concrete. So again, once care is taken when installing the system, but also as I said, during placement of the concrete, etc., that the system provided with everything interlocked and using the end comb fixings, that's not required. We do often see that, I say, there's details there to show bracing if required, if people have concerns over with it regarding the insulation and it won't stay in place. Again, I even know from my own experience that I didn't, at the very first time when I started using the system, that I didn't think that was going to be able for everything, but I was very pleasantly surprised at the strength of the system. That it is very true in itself. It's such a strong system that it can all stay in place once care is taken. Again, here you just see it's typical profile, a typical detail for a twin leaf timber frame unit. The concrete's in place, a temporary shutter is there. You can see just on the outside, there's a scaffold plank laid up against it, 2 blocks laid against that. So it's just providing an extra source of strength through the system, but it's more, again, peace of mind having it there, that if care is taken during placement and placement with concrete, that the system can stay in place. So here are just different examples of scaffold plank laid, as I said, against the external ring beam, and blocks are placed against the scaffold plank to reduce the chance of movement of the foundation system. And it's just a typical detail for this for an L profile. So you can have, again, the scaffold plank and blocks up against it, depending on the size of the upstand. If that are very strong, again, the end combs are in place. So during care of placement with concrete, there should be very little, if any, movement on the system. Again, just extra measures that people have taken at different scenarios of when they've used an L profile. So there's a timber laid across at a higher level where the concrete will be pushed, and there's some props coming against it. Again, the system is very strong and durable, and it does not have to require this system, but it's just there as an extra means, an extra precaution to ensure the alignment of the profiles during the placement of concrete.
Great, that's great. Thanks very much, Borg. So if anybody that is in attendance today has any questions about any of the misconceptions that we've gone through or anything about the foundation system in general, you can use the Q&A feature within Teams to submit your question, and we'll address those in order. So I guess just to get started, Chris, this one might be for you. Can you talk about some of the training provided to someone who maybe hasn't installed the system before? Pork, you might have some insight into that as well.
Yeah, well, there's a training program in place online, and then with Porrick and himself, and our technical manager Finian would also get involved in that, and also the design of the system as well, so that there's nobody's left to their own devices right across the whole process. So we've online training that must be done if you're going to design the system. But then on the install side, there's also an online training that must be done also, Brian, to start the process of learning how to install the system. And then Porrick is also then will do the same on-site practical side of the training as well. So it's key that that training is done. And then on top of that, if it is the installer's first time doing the system, once the system arrives to the site, Park will also be there for the first couple of days. Just to particularly go through the first install of that system. He will be on site the first couple of days just to go through that, to go through the type of things that the idea behind this presentation was to show those sort of 7 key questions that come up time and time again. And with Porrick now being with ourselves and being on site, but also not on site, a lot of what Porrick can do can be answered over a quick Teams call and also over a phone call as well. So supposed to give the people on the call the comfort today is that no one's left to their own devices. There's a hand-holding process throughout this from the design stage, and particularly if you haven't designed it before, and then again in the install side of things as well.
I think that leads us into maybe to mention some of the technical services that we offer, to new customers or to existing customers that have used the foundation. I don't know, Chris, if you want to maybe just go into a little bit of what we offer as far as from a technical perspective.
Well, on the system, I've covered that there, of what we do. You've myself, the specification manager, so I spend most of my time dealing with architects, designers, engineers to a degree as well around the system, but not just the system. All of our products. We have a technical team there of 6 people headed up by Finian. So the technical team would do the drawings for the system, and they would provide the training for the system, and then we do other things outside of that. So we can do U values, we can do condensation risk analysis. We've all the thermal bridging analysis done for the system as well. So we offer quite a complex offering there, and then we work with a couple of outside consultants agents. So if it's something that we maybe can't get done in time, we also have those guys there that back us up as well. So I suppose, right across that offering, we will then suggest on the density of the material. If it's maybe a void former for a project where you're concerned about the weight coming down on, we'll look at the density of that material. The thickness will be dictated by what the U value of the client is looking for. We'll do those U value calculations as well. So we offer quite a comprehensive service from the team there. And as I say, there's 6 in the team, and then including myself. So, we're always on hand to answer any question that anybody has.
Thanks, Chris. So we've got a few questions that have come in while you were talking there. So one from JP Architecture regarding waste. So this is a question I think we get asked quite often. Can you take back waste, particular with the F bracket profile snap off function? So I'm not sure, Chris or Pork, if you can answer that.
Yeah. Unfortunately, with the F profile with the snap off piece, that is the only piece that we can't take back. So EPS is fully recyclable as long as it's kept clean. And Porrick could correct me, but I'm yet to see an F profile snap piece come off without any concrete still stuck to it. So unfortunately, if the material's not clean, we can't take it back. The plus side to that is with the L profile and the F profile, the standard floor material that goes into the system, anywhere it's been cut for any services or anything, if the site's set that to the side, keep it clean, we'll bring it back and recycle it at the factory. And that also goes for all the floor projects that we supply as well. So we supply bags to the sites. We ask the sites any offcuts at all, put them put them into the bags, we'll take them back and recycle. So again, that's probably a misconception that we can add on to the back of porks, not for an install, but some people don't realise that EPS actually is fully recyclable. So we can do that. The one proviso on that is that it's totally clean.
Yeah, I think that's the big point there. It comes back clean.
It is. Yeah, it is 100%.
We have another question here, Pork. This one might be for you. It's from Jason. So it's relating to the underfloor heating pipes, fixed to the final layer of 300 mil EPS in the center. How or where is the underfloor heating pipes managed at perimeter thickenings?
It's a good question. So typically coming across thickenings, you can provide to be chairs provided or spacers provided to allow it to come across, so you're not bending up and down within thickenings. A lot of the times throughout the perimeter, the underfloor heat may not have to go to the full width of the perimeter thickening. That's always left inside off the wall. So that, again, that's looped across, so that can be fixed. To be looped across there at that place, you can have spacers. You can use concrete spacers. You want to minimise as much in the thickenings as possible, but say regarding the underfloor heating, they can go across that. They'll be clamped to the insulation. So for your perimeter thickenings, that would be a loop of maybe 300 mil coming around, but once that is clipped to the top layer of the insulation, that pipe then is not going to move. You'd have the bottom layer of mesh is already installed prior to the underfloor heating starting, so you can have a spacer set on top of that to, if there's concern of so the pipe will stay in its place, stay at the correct height. And then your high chairs are installed for the final layer of mesh that goes inside as well, which again you place around the pipes, so they can be fixed across through the insulation, say based off chairs and spacers.
Perfect. Thanks, Bork. Another question here, just relating to the compressive strength, I think. So what does 100 kPa ground bearing capacity translate into terms of ground conditions? Has the cost of the system been compared with strip standard raft to achieve the same insulation levels? So one for you, Pork, or Chris, if you can answer.
Yes, just regarding 100 kPa, so that would roughly be I can't remember the percentage now for CBRs. I think it's above 6%. Regarding CBRs, so once the ground is checked, so typically clay level and stuff like that, this can be checked. The probes can be done at it, or CBRs, the California bearing ratio tests are done to ensure that you do achieve the correct bearing capacity for the foundations.
And then just the question around the cost, has it been compared to strip standard raft to achieve the same insulation levels? I believe we even have a document for both the Irish and the UK market that is a cost comparison that was done by a third party that we can provide. I think in both cases, the foundation system comes out a good bit more cost effective when compared to a traditional strip or raft. Chris, do you have anything to add there?
Yeah, I mean it works out. So when we've done that analysis, that you're looking at the figures in that were around about 11-12%. That was done as an average across Ireland. When we got delving into it with, specific customers in certain areas, it was coming down in around 78%. So still a saving, which is, and it's a great saving as well. And I suppose, the other big advantage of the system, and one that is said to us a lot, and the reason that we're now, we're doing multi-unit sites, the other big saving for the system is time. Is time. So what we're finding now, the big sites will be getting the system designed, getting it delivered. As I said, it takes 3 to 4 days to fit the finished floor level. And then what we're finding, if you look at it, maybe a timber frame site, they're then ordering their timber frames, they maybe arrive on the 5th and 6th day and get them up. And we've a great case study there from one of our developers, which shows the money savings that he was having, and the program advantage as well. I mean, you're cutting your program down by 20 to 30%, Brian, which is, and more so in time as well. So the cost is a big saving, but the other one to look at is also the time and speed on site also.
Yeah, exactly. I think that's a good point to mention. So we have another question here. So as a non-construction professional, I understand now this system is for new builds. I have a traditional home that has no foundations, but the floor slab will be replaced. What system does Core offer for this situation, or where can I see all upcoming live sessions that might be more suited to me? So Chris or Pork, would we have a system that would be suitable for a traditional home, or?
Yeah, so there would be systems there. Now, typically, you may not be using the foundation system. You're going to base off what is there. So in that case, then you could use DPS 300 or EPS 100 sheets of insulation that's around. Again, it can be designed to suit whatever is required. It may not be typically a foundation system that's going to be, but definitely Core would have products or be able to provide products or services that would be able to suit any existing buildings that are being upgraded. So typically you would have the foundation there already from the existing building. So if it's just a case of you removing the floors, that would go into place there, so the floor insulation. If you were extending onto one, the design can be done. If you're extending onto an existing building, design can be compatible to allow for the new extension to be used with the foundation system.
Perfect. I think that that catches us up with all the questions that have been asked so far. If anybody does have any additional questions, please feel free to reach out to us through the website, through email, through Chris or Pork. All of our contact details are available on our website, and we will send around just a recap, a survey, and the recording of the session today to anybody that's attended. So feel free to reach out. Just as a reminder, if you do need a CPD cert, please email marketing@coresystem.com and we'll get that arranged for you. If there's no other questions today, I think we'll wrap up. So thank you to Chris and to Pork and to the rest of the marketing and technical team that assisted with the presentation today. And we will advertise any upcoming CPD sessions on our social media and on our website. If you'd like a CPD session at your architecture practice, Chris would be more than happy to arrange that with you as well. So thank you again to everybody that has attended today, and we will see you next time.
Thank you.
Thanks, folks. Thank you, Brian.